about infrastructures of chatbots, and then we'll do comparison between AI agents and chatbots. Then applications of agents, latest research on agents, LLMs, and the future of AI, and how can we adjust our skills to uh, develop our skills, how to match the future work. Okay, so let's start with large language models and chatbots, LLM. What actually those models? What is the infrastructure of those models, and what are they? How they are built on, and do they actually uh, understand English like us? Do they understand the words what we are speaking and how we communicate with them? Many questions come to our mind, uh, but many people use the chatbots, but few of us only wondered how these chatbots are working, actually work. So, what is the large language models? How they actually build? It's basically a huge story, but we will try to simplify a little bit these concepts. So we have, and basically it's neural networks. When we say neural networks, it's like millions of neurons. It's uh, connected with each other through uh, like uh, uh, math equation. There are relation between the layers, and through the layers there are in each layer there are uh, millions of neurons. We don't want to go through this so much, but we want to discuss how these understand the language. So we when we build this infrastructure, we train it on data, specific data, to understand our language. And there are multiple ways of understanding. There are multiple uh, algorithms. So it's not only one type of networks we have. We started with one type, then we moved to another types until we found like we the latest one which we have right now. We will talk about this, what's the type of it in the next slides. Now, at the beginning, when we started the ChatGPT, if you used the very first ChatGPT version, you'll notice a huge difference between that and now in multiple ways. The answers, the answers right now, it's more humanized, not like you will not feel like it is coming from a machine or AI. Previously, it was so, and again, it is depend on the prompts. So that's because of uh, algorithm called RLHF, reinforcement learning from human feedback. So we train the models on human feedback. Now let's move more deeper into how these models understand the text, or how the chatbots understand these huge prompts, or like these files, and does it actually understand English or not. So uh, basically, once we give a text to the model, immediately a transformer will do tokenizing the text. What is tokenizing? It is basically splitting the sentence into tokens. like the prompt, the whole prompt, it will split it into tokens. These tokens may be, it will be a full word or like 4 letters, 5 letters, depend. Every model will do it differently. Every maybe ChatGPT will do it differently, Cloud will do it differently, then Gemini differently as well. And after tokenizing, there is another process called embedding. Embedding, it is converting the tokens into vectors, meaning numbers. So if we want to visualize it in a better way, uh, maybe let's try to have 3D visualization. Every uh, token will be visualized in as a vector. And if we know the vectors, it is like a line and it has a direction. So an angle with a length and direction. So in a 3D space, we can visualize millions of vectors. The difference will be in the angle, in the lens. So we can visualize a lot of vectors. These will, why we are visualizing as vectors, because when I want to check for the similarity between tokens, then I can compare. Math always easier for us, right? To for the machine actually to find the best word, let's say, which will come next. So once we convert from tokens to vectors, then after that there will come self-attention. So self-attention, this is uh, why when we started the models previously, if you remember the ChatGPT, as we said, it was doing hallucination a lot. When we gave a prompt and the GPT will start talking about the solution, then at one point you start giving random things. This because previously the algorithm was uh, to build word by word and analyze word by word. At one point, the model will lose the sequence on the flow. Rather than that one, we are using now a new technique to process the whole sentence at once. But if I want to process the whole sentence and at one, I need to know the most important word in the sentence. Like, let's say, if you ask the model, I want to make a report for my daily work, for example. So there are few words in this sentence. Of course, it's it's not the huge attention there. It won't be having huge attention. Report will have huge attention there, like a huge weight on on the on in the word. Uh, Daily work as well. So to give self attention, also it will connect the word along with each other. So my report, so my it will connect it to report like this. So the idea is processing the whole sentence together, which this one uh, make the hallucination very less comparing with the previous models. So this is how when transformers started instead of the classic networks, then the new era of chatbots started. Then after we do this, we predict the tokens and we generate the output. After we process the input, then we start another process, which is generating the outputs, which is predicting the tokens. It will compare similarity based on the algorithms which we choose for the model. Here we will talk about, so we talk about infrastructures and uh, we will talk about the context window and memory. Prompt, context window, and memory. When we are using chatbots, all of us, we suddenly see uh, th- that the tokens over and our we consumed our token or the most important things when we are uploading a huge number of files sometimes the model will refuse that. They will say that you cannot upload that much of files for we can't the model cannot process this. This is related to something called context window. It is like I'll give you an example. When you are reading a book and while reading, you'll have short memory that you can remember last few pages, for example, like last 10 pages, let's say, what happened in the last 10 pages. This is a short memory. When you add more information, you lose the previous one. Like you lose number 11, the page number 11. This is called context window. How much the model can process at a time, like how much memory it can process, how much it can, like let's say it's called the short memory, how much it can store while processing, so, and without losing the flow. If you give too much context, it might lose the flow. Okay. Uh, also, we will speak about real, like RAG, the retrieval augmented generative. This technique is very important when we want to use those chatbots in our specific company. Like if you want to work or you want to use this chatbot, let's say ChatGPT, which can do many things and understand a lot of things. But on the other side, if you want to make it as a customer service, for example, for your company, uh, like, or if you want to use it in marketing for your company, even though ChatGPT or cloud is trained on a huge amount of data, but still will give, let's say, not correct 100% answers about your company or your organization. So to feed these models with our own data, this is where RAG is here. This is why RAG is here. To retrieve our data and feed the model where it can answer these questions about my company. Let's say Lab of Future. So I give the model information about Lab of Future, maybe about our courses, our webinars, our classes, and then the model. If someone asks the model or this chatbot about Lab of Future, anything, maybe pricing or something, it can answer. So this is when we feed data, we call it RAG. How this RAG work? It's so it's basically start with a user query. And when we have the when we build this RAG, we first make the data in a way that the model understands it. So, and what is the way that the model understands it? As we said previously, it's a vector database. The model doesn't understand real words, so it has, again, it has its own language, and it instead of the words, it has a token. So the model it deal with, or the AI will deal with tokens, and these tokens is uh, at the end it will be as a numbers. It will be deal as a numbers. The model will never understand English as we do. It's at the end it's math, the very basic things. It's a math, so we can't give the model a full documents and we say okay, read it, and every time the uh, every time the user will answer a question, you have to go to this PDF, for example, and read all the PDF and give me the information I need. This will consume a lot of time. It can do, but it's not efficient. We will consume a lot of tokens. We will consume a lot of time. It's not good. So instead of that, that's why vector is there. So vector database will make the process faster, consume less tokens. The finding the similarity will be very easy. So uh, and at the end more efficient in money wise and time wise. Okay. Now we what we discussed till now is chatbots. Chatbots where a user will um, have a chat along with the chatbots, and the chatbots will react. There is nothing automated, and there is nothing uh, like employee till now. There is no dangers on us till now. But the problem started when, or it's not a problem. It's we sometimes we call it a problem because we are scary from the new things only. But otherwise, it helped us a lot in our daily lives, and it make our tasks much faster. And yes, it's till now we can't use it for everything. So this is where AI agent come. It's not only can answer your questions, it can react. This is the uh, it can do. It's proactive. It's not reactive. So it will do the things without human interaction. It has a purpose goal, and it will plan and will do the actions. So, like for example, we have agents to for calling. Automatically, you can put the database and you can set the plan for the agent. You can give the way of how to call, how to talk, and the agent will call. You can put the plan as you want. The user will call and will do actions, send emails, send uh, WhatsApp messages, uh, update sheets. Like you can connect it to Google Sheets, and it can update these Google Sheets with whatever the inputs you or like the outputs which come from the plan which he's doing. Let's say he call a user, he call a customer, and this was a response from the customer. Okay, update the sheet with this response. Done. Maybe send an email report, weekly report, everything this agent can do. This is the loop where the agent will go through, plan, act, observe, reflect. It can go and it has a memory as well, so to keep things on track. We have multiple applications of AI agents, coding agents, research data analysis, business process automation, multi-agent system. Multi-agent system, it's where we have uh, multi-agents sharing the same goal. Example, we have customer support agent along with sales agents, along with accountant agents. So three of them, if inquiry came from the user, from the customer, all of three, if let's say there is one orchestrating agent, he's leading and orchestrating the flow. Uh, if let's say inquiry came regarding accountant, something regarding refund, for example, uh, so these will go directly to the accountant agent. He will reply. He'll take reply from the accountant. If something came regarding sales, so the same will do. So it's all orchestrating and it's happening in the same system. This it might be also one for coding, one for researching, one for reviewing. The points right now which research is going on, most important too is like reasoning, test time, and compute. Models think longer before answering hard problems. So we are trying to make the time less, which is like, yeah, of course, always we are trying to do this. Long horizon planning, this is very important point. And why? Because especially in robotics, in case if we are doing rescue task, robots will do rescue task. In this task, it's need a long time and it need planning, good planning. And the current AI might lose the flow. At one point, it might do something randomly to start doing hallucination. So we want to increase this long horizon planning so it can be more reliable. The agent benchmarks, it's just to evaluate the agents, how the performance of the agent, if it is fast and how accurate is it. And about the future, the most question we hear about, like, what we'll do, is it like our roles or our jobs will get over? Yeah, of course, no. We can't, the AI cannot work by itself. It needs someone to manage. It needs someone at the end to approve these. What till now, uh, AI made mistakes. Till now, yeah, human also made mistakes on the other side, but we need someone who has experience with dealing with AI also. So more people who can use AI, it's millions or thousands of jobs. It came also to the field because of AI, and not all of them need someone who know coding. Building an agent doesn't require coding always. These agents which we talk with, there are a lot of tools like N8N or different tools which you can create using just similar to block-based coding. You don't have to be a coder to do that. And so many roles came. Yes, some roles will disappear, of course, but new roles also will start. And just I think I believe that uh, the way we worked previously, it will change. It will not stay the same, yeah, of course, but yeah, hopefully we will be still needed. So yeah, this is like from assistant to autonomy, the journey. And thank you so much for listening. If you have any question, you can start now. Yeah, Nagrajan. Yes, please.
Yes, sir.
Yeah.
Sir, can we ever fully, completely eradicate hallucination to make AI not hallucinate? Or if you're using hallucination for good things, like let's say you're asking AI to make a poem for Father's Day. So the AI is basically technically hallucinating to say, "Your dad, you're the best," all of this. So, do we actually need to fully take out the hallucination, or do we only need to take off the bad part, or can we only take off the bad part?
Hallucination is not good. It's when you start talking, not you, I mean, when the model start answering on something different, like you ask on how to fix TV, for example, and the model suddenly start talking about the TV channels. It's
Uh,
when you link something with the subject randomly, it's
so,
I didn't get your point exactly, but hallucination is something, if we can remove it all, it's better.
so that's why. So hallucination happens when the AI confuses its tokens with another token.
Hallucinations start when the AI lose the flow. I
Ah,
You remember when I speak on the short-term memory
yes.
that I said the context window of the AI, it has a limit. So and then later it get improved when we start transformers, but before that it was limit. There is a limit uh, for the memory. And also previously I was telling you on the chatbots, when we were using previous uh, the previous algorithms of neural networks, it
Okay.
was instead of taking the whole sentence at once, we were taking word and then expecting and then the second one word and then the second one. And then when we reach a point that we forget the very first one, we start building on something random. And we start like, it was like, okay, after the word chatting, I will come with the word WhatsApp.
Okay.
Maybe it's not related to the flow because I lost the flow. This was previously happening with the models, but right now it's get better because uh, we we improved the algorithms of uh, processing the sentence or the prompt.
Uh, okay, so
Did
thank you.
Welcome. Mariana, will you have more classes? Yeah, I have classes with the lab webinar. I'm not sure these it come to social media team when we have webinars. So sorry, I can't answer this question. But classes, yeah, we have in the lab. Any more questions?
Hazim, questions are done.
Uh,
If
they
any of the participants have any questions, you can drop in the chat box and we have
yeah.
answer all of it for you. We'll take in few more questions and then we'll wrap up the session.
Till now we had 2 questions only. Let's wait for let's give maybe 1-2 minutes to ask questions. I mean to wait 2-3 minutes.
I'll share my screen.
Mhm. I'll stop sharing. Okay, I'll stop sharing.
My screen is visible?
Yes.
Okay. So to answer Mariana's questions, yes, we have a lot of classes coming on. And before telling all that information, let me thank Hazim for this amazing session today. And thank you
Thank
all for joining us today. And I hope today's session helped you explore AI in more exciting and practical way.
Thank you, Tirta.
And all of you joined here, you have earned 50 space credits. So what is space credit? So we have Lab of Future application. So log into the Lab of Future application and all the participants have been credited with 50 space credit. And how can you use that? I'm going to tell you that. Once you get into Lab of Future application, you're going to get three exciting things with your space credit. You can get special discounts, expert sessions, and exciting rewards using this space credit. So how do you do that? Log in to our Lab of Future. Here you can see 2 QR code. You can scan it and get the Lab of Future application in your mobile phones. And with your mail ID, just log in through and your space credit will be reflected there. So every week we'll have exciting activities coming. So join us and earn more credits and you can get your rewards. And coming up next week, we have Hazim, our AI trainer, with an amazing session. He's going to teach you the step-by-step process behind machine learning. So if you want to enroll for that, you can scan the QR code right in the screen here. I'll keep the screen ready for you. So you can, yes, Mahit, you have a question? You can on your mic and let us know.
Ma'am, I didn't understand what space credits were.
So, because you've joined today's session, you're going to get 50 space credits. So, once you log into our application, your space credits, so each session you're going to join with us, you're going to get more space credits. And you can utilize that for such webinars, such master classes that are coming in the future weeks. So, say this master class, you can utilize your space credit and get through this machine learning course. So such way you can utilize your space credit. Yes, Naranjan, you can ask your question. Nagaranjan, you can ask your question.
Nagarajan, that's my
Okay,
dad's
Nagarajan. Yes, Nagarajan.
name. Miss, that's my dad's name. My name is Akshat.
Yes, Akshat, tell me.
Yes, miss. What if you, miss, I already have an account on
Okay.
this one, on Lab of the Future. So will the credits be credited to my account that already existed, or will it
Okay,
be?
so you have enrolled with a mail ID for this webinar, right? So for that mail ID, you will get the space credit. But if you have any doubts, you can always message us at contact@Lab of Future. And even for the webinar which you attended today, you're gonna get a certificate too. So you can send your mail ID to this community@laboffuture.com. You can click a picture of this and then you can send your full name and our team will share your certificates.
Okay, miss.
Also,
Thank
if you have any other doubts regarding the app or any of it, our team can help you out. So you just
you.
have to send a message to this mail ID.
Okay, miss.
Is
Thank
it
you, miss.
clear?
Yes.
Okay, perfect. So thank you everyone once again. Thank you Hazim for this amazing session and thank you all
Thank you
students who
so
have
much.
joined us today. Thank you. Thank you. Bye bye.
Give me this bonus.
Bye.